Hello, Jim Mcgrew here. Not sure if I've got the volume too high or not, but I want to make sure that you can turn it up or down. This is a small video on a component of how I use Aspire software to in my cabinet business with radius front desk and part production. There are a lot of ways to do this. You can use a variety of CAD/CAM engines to do exactly the same thing, and I'm sure others will post how they do it. But I looked for a reasonably cost way when I got into CNC, and this is what I use. When you get a job, you're going to get a set of plans from an architect, hopefully, unless you're designing it. So what I'm going to do today is show where I received a set of plans from an architect for a dentist facility, and basically what we're going to work on today is this radius front desk right here, and how to fabricate it. One of the issues and why I want to pre-make this desk before they put the walls up is, if I got nice straight runs and angles, and if you can't do nice straight runs and angles, then find another trade right now. But in the area of radiuses, this is where the CNC really excels. But if you notice, this little wall comes out right here and then begins the radius, right? And so, how are we gonna do that? Get it perfect, get it in on time without a lot of scribing. How can we pre-make it in the shop, and so forth. So this is the floor plan, and shows the countertop, the upper top, and the rest of the countertops in the wall that it will match into this area here. At that point, I go back to another plan, or the second page, which is the dimensions drawing. Let me move it up here where you can see it, and you'll see that the wall where it's going to marry to here is a 5-foot radius, and that's the magic number. Now at this point, you can call the architect and ask them to send over what's called the AutoCAD drawings to their language, sometimes known as the DXF or the DWG files. And if you get those, you can use them to use that radius, but it's really not that difficult to do it in Aspire now that you know the radius. Again, because I am setting the standard here, what I do is call up Aspire, and we'll bring it into the program here. And if you can see what I've done, or basically I go in and I just start me a circle with a 5-foot radius. You can see it over here on the left hand side. I create that, and just to show you how I do it, once you select those vectors, that's what those little red dots are there. And I'm no engineer, so I don't know how to explain all this, but it's basically the language that tells something where to move on a screen. I go into what's called node editing, which you'll see has divided that 10-foot into 4 parts. And I'm going to cut one vector there, cut one vector there, grab the rest of it and delete it, and then I now have a radius. We know that that is our 5-foot radius right there. So what I'm going to do at this point is to turn and rotate that. Whoops, that's not my rotate button. That's not my rotate button. I'm going to rotate it 45 degrees, and I'm going to spin it around until I get it where I want it. Okay? And now, that would be the inside profile of a 5-foot radius in that counter. And by the way, the white area that you see on the screen is typical of a 4x8 sheet of substrate, in this case plywood, which we would use for the top and bottom plates and the substrates of the countertop. I'm going to take that 60-inch radius, and I know that my countertop will run basically 25 inches in of that point if it were scribed to that point. So what I'm going to do is I'm going to take, remember, this is your baseline all the way through this thing. This is going to be your baseline. And what I'm going to do is I'm going to take that line, and I'm going to do what's called an offset, and I'm going to set it in 25 inches. Now what you've got is a 25-inch slice out of that plywood, And by taking that piece there and now doing a moving outwards 3 inches, I can take those 2 vectors, copy, paste, and move them up. At this point, I'm going to use a little connection tool. If you notice, what I did was I just connected the vectors on the end, and I've basically just cut the piece which will be the buildup on the inside of my countertop. I'm going to set that off to the side. And now I'm going to take this one and I'm going to do an offset outwards of 0.25. Why 0.25? Because that's the thickness of the skin on the inside of my wall. Okay? Now I'm going to take that one and do an offset of 3.5 inches. And do an offset. And again, I'm going to capture that. And I'm going to connect 2 ends. Grab that part and pull it off. That is the top and bottom plate of my wall. Okay? Now, if you remember, I still have this one, so I'm going to do one more thing, which is to do an inwards of 3 inches offset. Whoops, that's not what I wanted to do. I did not mean, I'm going to go back here and hit undo and not close that vector. I'm going to take that right there and I'm going to go back and I'm going to do my offset of 3 inches, close, catch that part, connect it, and that part is the buildup of the inside of my countertop, which goes with this part over here. And I'm just moving them off the screen right now. At this point, I don't need this one. Well, yeah, I do, because I take this one, which is my outside, and I move it outwards 25 inches again, because I used my part. Okay, I grab that one and connect them. And I'm going to move them out of the way temporarily. I don't need these anymore because they were basically guides. And what I've done is I've created the vectors for my parts. And at this point, I'll go through this with you. Let me just move that one out of the way so I don't conflict with anything right now. At this point, I'm positioning this on my sheet so that it's on my sheet. And I want to optimize and get all I can out of my sheet of plywood. So I'm going to see if I can get a full, yes I can, by positioning that on the table there a little bit. I can get a part out of my one part of my wall built. And actually, I think what I like better is doing all 4 parts of my wall on a separate sheet. So, because I can see how, if I put this in the center, and I bring my inside build up in, let's see if I can position them a little bit so I get a good nest here. That's about as tight as I'm going to be able to get that. And if I spin that up a little bit, I believe I can get all 3 parts on a sheet. At that point, you know, you back into your CNC, I go into tool pathing, I pick a profile cut, I want to cut through at 0.755. For the sake of this demonstration, I'm just going to use a 1/4 inch end mill, and I'm going to select the pass depth at about 0.25, so it'll cut through in 3 passes, just for the sake of an argument. And that's in tool pathing and all that, which you'll learn more about. I want to be cutting on the outside of my vectors, and I calculate. It asks me if I want to cut through my material. The answer is yes. I want to preview all toolpaths. It cuts out all my part, and when I delete my wasted material. Now I've got all my countertop parts. I've got my inside radius and my outside radius of my buildup. I've got 1/4 of my countertop. I cut 2 sheets. I've got the entire countertop done. To go back real quick and just move those out of the way and go back to my wall parts, which I need 4 of. I go to 1 sheet, and Aspire has a nice little function here called copy and array or nesting. You know, a lot of ways to do it. I'm going to use rectangular array. I want let's see, I might be better off to do this with nesting. If I pick a nesting, I need 4 parts. Looks like everything's good. And there are my 4 wall plates. Missed one in my grab. And again, I can go in and I've already set my toolpath, so I simply calculate and it says it's going to cut through it. I reset the preview. I preview all toolpaths. Of course, it's cutting them all now because they're all still on the, I got both toolpaths turned on, which is not what I wanted to do. So I'm going to reset the preview. Just pick preview number 2, preview that toolpath, and delete the wasted material. And there are my 4 top and bottom plates for my wall, which make up the entire radius of the wall. At this point, I'm going to go ahead and show you kind of what that looks like when you get it done. And here's a screenshot in Picasa of that desk that we did. You can see where we come in and we basically help dictate exactly where that wall went, and it comes out straight on the other side. And everything after this now, because this follows the form of the sheetrock wall, everything after this is angles and straights. And you know, again, I'll make my top countertop because I've got my DXFs. We basically leave this in the field for a few days while they get the framing married up to it so that we get a nice marry up. We come back and we get it, or you can just basically trust them and leave the lines on the floor. But I wanted nice flat walls to look real good. Want a very beautiful job. I like doing things once the right way. That $60 trip to send somebody out there to set it up and let them have it for a little while is worth its weight in gold in the value of a completed job with no punchbacks, no hours of scribing. You know, everything just bolts together in the field. I hope this has been helpful, and that's a little bit about how I use Aspire to make parts in cabinet making. And maybe today I'll try to get into arches and some other things. Anyway, I use CamMaster CNCs and Aspire software. I've got Cabinet Vision and Cabinetware. I've got others, but those are my primaries. And I really enjoy the stuff I work with and the people I work with. They're good companies to work with.